Hi, Chem 108. So I'm Tara, and this is my extra credit video project. So today I'm going to be talking about naming alcohols, and I'm just going to refer to my PowerPoint slightly, but I'm just going to actually be writing out examples on my little makeshift whiteboard. So for naming alcohols, so when you think of the word alcohol, probably what comes to mind is like the adult beverage, like you have your liqueurs or your wine or any of that stuff. And then another thing that I think of is like rubbing alcohol, which is what you take off of nail polish, which is literally sitting on my desk right there. But the actual textbook definition of an alcohol is alcohols contain one or more hydroxyl groups, which is, if you're trying to picture that in your head, it's the -OH, the like definition of the way the hydroxyl group literally looks. And that hydroxyl group is attached to a carbon. So the key point for an alcohol, it has to have one or more. So the general form for an alcohol, just so that you guys get an idea of like kind of what it looks like, is basically just pretty simple. You have your group and you have your hydroxyl. And so one or more, this is the key point. You're going to have one or more of these guys. So I guess just a simple example to start us off would be, let's just go with ethanol. So that guy is pretty simple, and you'll see the exact same thing of the general form. You have CH3, CH2 attached to your hydroxyl functional group. So pretty simple, and if it has one or more, that's going to be an alcohol. So going to my PowerPoint that I made, pretty simple, but there are just a couple key things in mind when you're naming alcohols, which is going to be your classification and your naming of just the simple breakdown of actually how to do it, which if you write it out and you follow the steps, like I like lists. So if you follow the list, you cross it off, it's actually pretty simple. So I will try my best to teach you guys how to do that. But the first thing for classifications is you're looking at your primary, your secondary, and your tertiary. So if you kind of think of it, it sounds like 1, 2, 3, which is easy to remember. But basically, the definition is kind of in the name. Primary, you just have attached to one R group. Secondary is 2, tertiary is 3, so on and so forth. So an example of, just let me get here. Oh my gosh. So an example of, I guess, something that would be, let's just go with primary. So 1 would be this right here. So I kind of tried to roughly drew it out for you. But here you have your R group, your carbons, your hydrogens. You get the point. Oh, and then of course your carboxyl group up there, my O. So yeah, 1, 2, 3, just make sure you correctly identify if it's primary, secondary, tertiary. And you can just easily, it's pretty simple. If you look at them, you find the R groups, and they're usually together. So that is what helps me, at least. And then the steps. So my steps that I wrote is basically 1, find and name the parent chain. The parent chain, we've gone over this a lot in other chapters, but the parent chain is the one with the longest continuous part of the carbon, so the C's, attached to the hydroxyl group. So look for the OH, count the C's, that's your parent chain, the longest part. Number 2 is name any alkyl group substituents. So think of those as the extras, the little extra frills on there. You have the parent chain, you have your attached hydroxyl group, and then let's say you count 1, 2, 3, there's a line down on it, and you see a CH3. There could be a methyl group, an ethyl group, any of those things are your substituents. So obviously include those in the naming. 3 is determine the point of attachment of those groups to the parent chain. So counting from the hydroxyl group 1, 2, 3, 4, 5, obviously whatever one the alkyl substituent group is attached to, write that in the name. 4 is construct the names of it by placing alkyl groups in ABC order, alphabetical order, and figuring out position and number followed by the name of the parent chain. So again, I'm a visual learner, so I'm going to try to give us an example of that. So if I wanted to draw out 3-methyl-3-hexanol, because I feel like that's just a pretty one. Or actually, let's start with an easy one. We're going to draw out methanol. Keeping it simple, no substituents, no extra frills, basic. So methanol I like to start out with the easy guys. Simple. This would obviously be a primary because you have your R and you have your OH. Now, if we wanted to get fancy, let's do the 3-methyl, 3-hexanol. Let me just draw it out for you guys. Obviously, if it's hexanol, that's going to tell you how many carbons you have in it. I mess those up, so make sure you know all of the names for it. Now, okay, if we were here looking at this, how to name. You have your OH group. You're going to count from this part because this has 2 carbon hydrogens. This has 3. So this would be 3, 4, 5, 6 because it's hexanol. You have your substituents, and this would be on number 3 right here. This is why it's a 3, and this is a methyl group. And your second one, which is your hexanol, because you have your carboxyl group on number 3, which is why it is 3-methyl, 3-hexanol. So if you follow the simple steps of the classifying it as what it is, primary, secondary, tertiary, and following the steps for naming, parent chain, name the substituents, alkyl groups, determine which number it falls on, and then putting it together correctly with your dashes and your spaces, you should be good to go. So anyway, thanks for listening, and I'll see you guys hopefully next semester on campus. Fingers crossed. All right, bye guys.